In this video, we're going to talk about values and visibility. So machine learning systems are really the foundation of AI. Machine learning often involves deep neural networks with billions of parameters. Very difficult to know exactly why it came up with an output that it came up with, which could be a decision, a prediction, a recommendation. It's one thing if we're talking about a recommendation for a movie that you might like, a song you might prefer. It's another thing if we're talking about healthcare decisions, financial decisions, a loan approval or rejection. Then it gets a lot more challenging and we get into a lot of ethical questions. So we're going to dive into that here. To start out with, I absolutely love this comic. So this is your machine learning system. Yeah, you just like keep pouring things in and stirring it around until you get the answers that you want. And to some degree, this is what happens, right? We don't actually program these systems to do exactly what we want them to do. We let them figure out the answer. How is it doing that? Well, there's different models and different techniques that it can use. But we still, with these really large, complex models, it's still really difficult to know what patterns did it actually learn. What are the actual patterns it's using to make those decisions? So just to make this point crystal clear, in classical programming, programmers are writing explicit rules. If this is the case, do something, do X, Y, Z. Otherwise, do A, B, C. Accounting systems would be a good example. They're generally very strict rules. I know there's some interpretation in GAAP and things like this, but for the most part, they're kind of clear cut. Now, we talked about like a Netflix movie recommendation. So in this case, yeah, I mean, you could start to write out rules for, what type of a movie would a person like? Well, they watched horror movies before, so they probably like other ones. And that's true, but there's more nuance to it because it might also involve other different types of genres put together, particular actors or actresses, whether it's period pieces or historical fiction. And there's just kind of, whether the movie's good or bad, what audiences think of it, what critics think of it. Some people like critically acclaimed movies, whereas others just like the popular kind. So I think if you tried to just write out by hand all of those rules, there would be a million exceptions you would not do very well. So in machine learning and AI, we just give it the data and an algorithm and let it figure out the pattern. So of course, like I said, the problem then is, so how do we trust this? Because this is a challenging issue. I don't know why all the time it came up with the answer that it did. And this, of course, is what we call the black box problem. Now, even the engineers of these really large systems don't always know. So there are teams at Anthropic, for example, does a lot of research in what's called explainable AI. It's actually an area that I'm doing research in as well, where we can start to piece together, and this is often in terms of large language models. So smaller models, some of them are interpretable, we can understand, but large language models, for example, very difficult to know. And even the researchers in this field pick out small little parts and they get understand little bits and pieces of what's going on. But this is a large math function with over a billion parameters. So just thinking about that for a second, it's very difficult to understand fully. So how then do we trust it? So if we don't understand the internals, we can look at from a behavioral perspective. Well, 99.9% of the time, it's giving me the right answer. Okay, well, what about that other time? And you see this with hallucinations in large language models as well. I've seen some data that hallucinations, instead of getting better, are actually getting worse. So how do you know when the system is giving you correct information? And this is why it's critical. You always need to evaluate the results, think critically, figure out not just what questions to ask, but how to critically evaluate those answers. And so you get this mechanistic or behavioral view. This kind of ties into the Turing versus Searle discussion that we had in the first video. So this was a really fascinating study where this Google AI system in the controlled study, the quote-unquote patients, they were brought in for the study in particular and kind of simulated. They weren't actually dealing with those illnesses, but in kind of a Turing test-like scenario where sometimes you get an actual physician who would respond to you, and then sometimes it would be this AMIE system. In general, overall, people actually preferred the AI system. And there's the link if you want to go check out this article. Very interesting result. And I don't know. I mean, some doctors have better bedside manners than others, but I don't know that would you want to have your healthcare decisions done by an AI system? And of course, there becomes the issue. So if a mistake is made, who is responsible for that? Is it the people who built the system? Is it the hospital in which you were getting the care? These are very difficult questions. Now, all systems, all machine learning and AI are based on data. So if the data that came in was biased, you're going to get some bias in the output as well. There are many techniques to try to deal with this in the training of the systems, but mistakes can be made. Of course, you have privacy issues as well. Now, I think in the end game, the answer is really there's always a human in the loop. So in terms of the medical field, and medical imaging is a great use case for this, like huge automation advances. We're able to look at, in some cases, many more images. A computer can do that faster than a human. But in the end game, right, I think you want AI to be that assistant. So you have an actual doctor who is reviewing this. Just like if you're using AI to help do research, you would verify the answer, verify the responses that you're getting, thoughtfully consider how you would use what it's giving you into any research that you're doing. It's an assistant. It's helping you do the thing, not doing the thing completely for you. Because at that point, then what value are you adding? But in this medical use case, this is really key because the AI assistant can be a huge help, but you need that human to also take a look then and say yay or nay, approve or not. I want to look for 1 minute at this context diagram I created just to show there's a lot of parties involved. If you're thinking about, who's responsible or who helped make this happen, blame or praise. So there's the original data sources that you get data from. There's the algorithms and the models that someone needs to choose to put that data to use that feed into the AI system. There's of course also the organization that deploys this technology. They have staff. So let's say in our medical example, this is the hospital or doctor's office. And then the user of the AI system, so that would be your doctor, nurse practitioner, a lab technician, staff member at the hospital, and then of course you are the impacted party. You're the one receiving the care in that use case, in that example. So there's a lot of people involved, a lot of pieces and parts, and I think it's going to take a while to figure out what is the right level of controls or regulation or quality assurance and testing. And that's why I say for the foreseeable future, for quite some time, we're going to have a human in the loop. We're going to want to have a human in the loop for these critical decisions, certainly for healthcare. And even for things like financial decisions, this is why Europe has the requirement that you need to have a right to be able to understand why this decision was made, which can be a challenge for some of these systems because, as I said, these are complex models, and so you need to be able to have an explainable result. So then getting down to the key question, would you want to receive healthcare from an AI doctor or a human one? And if it's an AI, under what conditions would you be willing to do that? Would you want to know exactly how the AI got to that decision? Would you want to know its accuracy rate? If you got the information from a regular doctor, would you want to know those things? So, this is a philosophy class, but these aren't just academic decisions. These are going to be real world decisions I think we're all going to face as AI becomes a bigger part of our life. So I hope that you enjoyed that part. I think these are fascinating discussions. So I'll see you in the next video. Thanks a lot.